So let's do a very simple numerical version of the calculation of the effects of a tariff on an industry that's described by a very simple supply and demand curve. So we've graphed the supply and demand curves here, and I tried to graph them roughly to scale here. So for example, if the price is equal to 0, then demand is equal to 26, so that's why I put that down here. So you can do that likewise for the supply curve. So here's the demand curve, here's the supply curve, and we find the equilibrium price by setting supply equal to demand, and we can easily solve that to see that P is equal to 4, so we mark that here. And that's our initial no-trade equilibrium. Let's suppose that in this economy the country can import at a world price of 2, can import it as much as it wants. At the world price of 2, then, the supply domestically will be equal to 10, and the domestic demand will be equal to 22. So you can plug the world price of 2 into the supply and demand curves and check that yourself. And then the difference between supply and demand is imports, and imports are equal to 12 in this case. So at the price of 2, domestic supply is pretty low, domestic demand is pretty high because the good is now cheap, and so there's a lot of imports. Now we ask what happens if we put a tariff, say it's equal to 1 on the good, so the world price is now going to be equal to 3, so the price domestically rises, and we want to calculate the effects on consumer surplus, producer surplus, the change in the tariff, and the deadweight loss. So if we start first with consumer surplus, we let's change the pen here. Consumer surplus, you'll recall, is this whole area, and we can think of that as a rectangle. That's this rectangle, and then this triangle here. So the rectangle has a length 20 and a height of 1, so that's 20, and the triangle has a length of 2 and a height of 1, so the area of your triangle is base times height divided by 2, so that's 1. So the change in consumer surplus is equal to 21, and remember that's a loss. So now if we want to go look at the change in producer surplus, we remember the change in producer surplus is the area below the new price and above the old price, and so it's this area here, which we can think of as again a rectangle and a triangle. The rectangle has length 10 and height 1, so that's just 10, and the triangle has length or height 4 and base 1, so it's 4 times 1 divided by 2, which is 2. So we have 10 plus 2. That 2 is the area of the triangle. So that's equal to 12, and that's an increase in welfare, right? The producers are better off from the tariff. We also have the tariff revenue, which is a benefit we can think of as to the people in the country, and that's a rectangle with length 6, right, and height 1, so that's 6. So we have a loss of 21 and a gain of 12 and a gain of 6. The loss is bigger than the gain, so the deadweight loss is 3, 21 minus 18. And that 3 loss corresponds to our deadweight loss triangles, which we can think of as here and here. And these two triangles, right, if we measure them, one has length 4 and height 1, so that's 2, and the other has length 2 and height 1, so that's 1. So the two triangles indeed add up to 3, and that's the deadweight loss from the effects of the tariff. So given that the geometry of the supply and demand curve are pretty much the same for every situation, the downward sloping demand curve, upward sloping supply curve, a tariff always has a net negative effect on welfare of the country, but of course it's redistributing welfare from consumers to producers. So producers are going to be in favor of tariffs and consumers are going to be against tariffs. And that's what a simple numerical example can help us to see that strong logic of the distributional effects of a tariff.